Hello, everybody. In this episode, I'll be speaking with Beth Barnes. Beth is the co-founder and head of research at METR. Previously, she was at OpenAI and DeepMind, doing a diverse set of things, including testing AI safety via debate and evaluating cutting-edge machine learning models. In the description, there are links to research and writings that we discussed during the episode, and if you're interested in a transcript, it's available at axrp.net. Well, welcome to AXRP.
Hey, great to be here.
Cool. So, in the introduction, I mentioned that you worked for Model Evaluation and Threat Research, or METR. Like, what is METR?
Yeah, so basically what we're, basic mission is have the world not be taken by surprise by dangerous AI stuff happening. So we do threat modeling and eval creation, currently mostly around capabilities of evaluation, but we're interested in sort of whatever evaluation it is that is kind of most load-bearing for why we think AI systems are safe. So like with current models, that's capabilities evaluations. In future, that might be more like control alignment evaluations. And yet try and kind of like do good science there, be able to recommend like, hey, we think if you measure this, then you can rule out these things. You might be still concerned about this thing, like, here's how you do this measurement properly, here's what assumptions you need to make, this kind of thing.
Gotcha. So mostly evaluations, but it sounded like there was some other stuff as well, like threat modeling you mentioned.
Yeah. And yeah, we also do more like policy work, recommending things in the direction of like responsible scaling policies. So saying what we think, what mitigations are needed based on the results of different evaluations, and sort of roughly how labs or governments might construct policies around this, like how evals-based governance should work roughly.
Okay, so should I think of it as roughly like you're an evaluations org, you want to like evaluate AIs. There's some amount of threat modeling which goes into like what evaluations should we even care about making. There's some amount of like policy work on the other end of like, okay, if we do this evaluation, how should people like think about that? What should people do? And it's sort of like inputs to and outputs of making of evals. Is that like a fair?
Yeah.
Cool. So if it centers around evals, like what counts as an evaluation rather than like a benchmark or, some other ML technique that spits out a number at the end?
Yeah, I mean, I guess the word itself isn't that important. What we're trying to do is that we have specific threat models in mind, and we're trying to, construct some kind of experiment you could do, measurement you could run that, kind of gives you as much information as possible about that threat model or class of threat models. So like, whereas, generic ML benchmarks is sort of like, don't necessarily have like a specific goal for what you're measuring, or you might more be trying to you might have a goal for measuring something that's more like a particular type of abstract ability or something, whereas we're trying to more work backwards from the threat model, and that might end up getting distilled into something that is more like a ML benchmark, where it's like looking for some particular cognitive ability, but it's sort of working backwards from these threat models, and we're trying to be careful about thinking about exactly how much evidence does this provide, and like how much assurance does it provide? What do you need to do to implement it properly and kind of run it properly? I guess that's maybe another difference from a benchmark is like, usually is just like a data set, whereas we're thinking more like a protocol, which might involve like, okay, you have this like dev set of tasks, and you need to make sure that you've removed all the spurious failures of your model running on that dev set, and then you run it on the test set, and you look out for these kind of things that would like indicate that you're not getting a proper measurement, and things like that. So it's like a bit more end to end. What do you actually need to do, and then what evidence will that give you?
Gotcha. So yeah, in particular, I think one thing I think of as distinctive about the evals approach is that it's more end-to-end, right? Like you're taking some model and checking if you can like fine-tune it and prompt it in some way, and at the end you want it to like set up a new Bitcoin address on some new computer or some other random task. Like if I think about most like most academic research in AI is a lot more just sort of thinking about fine-grained, like can a model reason in this specific way, or can it do this specific thing, or is it representing this specific thing in its head? I'm wondering, like why did you choose this more end-to-end approach?
Yeah, I think it's just hard to, know exactly what the limiting capabilities are. The question we're actually interested in is, could this AI cause catastrophic harm, or like what mitigations are required to prevent catastrophic harm, or to get the risk below a particular level. And then, like that already creates difference. You might say like, oh, well, you can go straight from that to like, you just like directly identify the kind of key cognitive capability that's missing and measure that. I think that's just hard. And like that would be great if we could do that. Like if we have something that's very quick to run, it's like, oh, we've kind of like extracted the core thing that's holding these models back, and now we just need to look for that thing, and we can see like as long as that hasn't changed, like everything's fine. But I think we do actually want to work backwards from something that we think is like a better proxy for danger, and see if we can distill that into a some more specific underlying capability, as opposed to going straight to some particular dimension or particular property without being sure that that's linked in the way that we want to sort of the real world outcomes we care about. So I guess I kind of think of, there's like we're kind of trying to build a series of chains. So like on one end you have what actually happens in the real world, which is, sort of what we're actually concerned about and what we're trying to be able to rule out, or, say that you need to do particular mitigations to prevent. And then, working back from that, you need to turn that into experiments you can actually run sort of at all. Or even first, so you have like threat models, you're like, what is the story of how something very bad might happen? Then you go from that to what activities does that involve the model doing, which may not necessarily be super straightforward. Like when we've been thinking about the autonomous replication, it's like, okay, what challenges actually do you face if you're trying to find compute to run a big model on, or something, there's various like what activities are actually involved. Then once you know the activities, you're going from like, the idea of a particular activity in the world of like, oh, it might be like, I don't know, finding criminal groups who will let it, it can pay to use servers even though the government is trying to, prevent this from happening, or something like that. And then it's like, okay, how do you go from that to like a task that you can actually code and like run in a repeatable way, and that's going to lose various kind of real world properties once you actually kind of make one specific task, and you can't have the model actually doing criminal things. Like you can't be like, oh, a task is like, can the model carry out a targeted assassination on this person or something, like and even just like there's just like a bunch of constraints for what you can actually run. But the sort of most realistic kind of evaluation might be this long task over, that you would expect to take multiple weeks and, maybe spend thousands or tens of thousands of dollars of inference on. That's sort of like your best proxy for the actual threat model thing. And then you wanted to go from that to like, a larger number of tasks to reduce variance, and like they're shorter and cheaper to run, and, generally have more nice properties, or they're not super expensive and complicated to set up and things like that. And then ideally we go even further from that to distill like, oh, here are the key hard steps in the task, or like here's, we went from this like long horizon RL task to some shorter RL tasks, or even to like a classification data set of like, can the model recognize whether this is the correct next step, or like, can it classify the appropriate strategy, something like that. So we're kind of trying to build this chain back from what we actually care about to, what we can measure easily, and even like what we can forecast and extrapolate of like, well, will the next generation of models be able to do this task, and trying to kind of like maintain all of those links in the chain at as high fidelity as possible, and kind of understand like how they work and how they might fail.
Fair enough. So I guess like a way I can kind of think about that answer is saying, look, we just don't have that great theory of how neural nets are thinking, or what kinds of cognition are important, or how, like some set of like some pattern of weights is relevant for some real world thing. If we want to predict real world impact, we should just like we can kind of think using the abstraction of tasks, like, can you write code in this domain to do roughly this type of thing? And we can reason about, in order to do this task, you need to do this task, and like this task is harder than this task.
Yeah.
And like that kind of reasoning is just way more trustworthy
Yeah.
than other kinds of reasoning. Is that a fair summary?
Yeah, I think so. Like that. Yeah. And I think another thing about academic benchmarks historically is they've tended to get saturated very quickly. Like people are not that good at picking out what is really the hard part. And I guess this intersection with like what you can build quickly and easily is in some sense adversely selecting against like the things that are actually hard for models, because you're picking things that you can like get your humans to label quickly or something, or things you can scrape off the internet.
Right.
These often tend to, like, models can do those before they can do the real tasks, and like that would be a way that your evals can be bad and unhelpful is if you have this data set that's like supposed to be really hard and supposed to be like you can't do it. There's a long history of people thinking that things are AGI complete, and then the model does it without actually, does it in a different way. Like models have a different capability profile than humans, and this can mean that like something that is a very good measure of whether a human can do a task, presumably, medical exams or legal exams are a pretty good proxy of, how good a doctor you're going to be. They're obviously not perfect, but like they're a much worse predictor for models than they are for humans.
Yeah. I guess it's kind of an interesting, like, to me, it brings up an interesting point of like a lot of valuable work in AI has been just coming up with benchmarks, right? Like coming up with ImageNet, like you do that and you sort of put a field on a track. And yet, like in many ways, it seems like the field treats it as sort of like a side project or something of an afterthought. And like, I don't know, I guess there's some selection bias because I pay more attention to the AI existential safety community. But but like when I do, I see them be much more interested in like benchmark creation and just like really figuring out what's going on than academic researchers, which in some sense it's not obvious why that should be, right?
Yeah, I feel confused about this with like interpretability as well. There's various things that are just like, surely if you're just like a scientist and want to do good science, you would be doing loads of this, and like it's really interesting, and like I was kind of like surprised that there isn't more of this. And yeah, there's a lot of very low quality data sets out there, that people make kind of strong pronouncements based on like, oh, the model like can't do theory of mind based on this data set, and you look at the data set and you're like, oh well, just like half, like 20% of the answers just seem wrong, like
right. Yeah, I wonder if it's one of these things where just like adding constraints helps with creativity. Like you look at people with like extremely weird, like nonsensical political convictions, so they just end up knowing a lot more minute facts about like some random bit of the world that you've never paid attention to because it's like one of the most important things for them. And like it's possible, like just by the fact of like AI existential safety people being kind of ideologues, it like helps us, have ideas of like things that we care about and look into, and like
I don't know. I mean, I don't know. Definitely not the only people who do good ML science or whatever. True. I do think there's some amount of like, actually trying to understand what the model is capable of is somewhat better than academic incentives, and it's easier to like get funding to pay large numbers of humans to do things. I think there's also various stuff with eval or data set creation. It's just like not that fun. It's just like a lot of schlep and like organizing humans to do stuff and like checking that your data set is not broken in a bunch of dumb ways, and like by default it is broken in a bunch of dumb ways, and most people just like don't want to do that, and you get a reasonable fraction of the academic credit if you just like put something out there.
Yeah, and I guess somehow the people who would be good at that aren't like entering PhD programs as much as like we might like.
Yeah, I don't know how much there's just like, I haven't seen that much evidence that there are these really good benchmarks and they're just inside labs. Like that may be true, but I don't particularly have reason to believe that labs are super on top of this either.
Sure. So yeah, speaking of just what evals are good, and I guess I'm wondering what's the state of the art of evaluations? What like can we evaluate for? What can't we? And what's like maybe in a year?
Yeah. Okay, yeah. There's a few ways to split this up. There's like domain, and then difficulty level, and then something like, what confidence can you get to? Like, how rare are the worlds in which like your measurements are totally wrong? Like I think there's I don't think we've totally ruled out a world in which like with the right kind of tricks, some model that's not that much more advanced, or maybe just even just like somehow you do something with GPT-4 and it like is actually now able to do way more things than you thought. And I think just like the more people generally try to make models useful and it doesn't improve that much, like the more evidence we get that this is not the case. But I still don't feel like we have a great systematic way of being confident that there isn't just some thing that you haven't quite tried yet that would work really well. Like I have some sense that, there's a bunch of ways in which the models are just very superhuman, and the sort of fraction of the capability that we're really using is quite small. And if they were kind of actually trying to do their best at things, that you would see much higher performance. But so I think this is one of the limitations. I think that will probably persist. I do think there, like something I would feel much more reassured by in terms of bounding how much capabilities might be able to be improved is like, you have a fine-tuning data set that the model can't fit of something that's sort of clearly necessary in order to do the task, which I think would look like recognizing is this strategy promising? Do I need to like give up and restart, or like should I try something else now? Like did I make a mistake? You imagine like creating a classification data set based on sort of key decisions you need to make, and showing that even with fine-tuning, the model just like doesn't learn to fit that classification data set. But as far as I can see, most cases, like if you can collect a reasonably large data set, then the model will just kind of do comparatively well to humans on it. Like we don't have good evidence of upper bounds, but we haven't seen like huge gains of wow, you just this one weird trick and now it's way more capable. Like we've seen pretty large gains, but more like OpenAI has continued doing a bunch of post-training and GPT-4 is getting better and better, as opposed to like someone just figured out this prompting trick and now it's like totally crazy. Like when we evaluated GPT-4 pre-deployment, we had some forecasts of like how quickly the kind of public elicitation would surpass us or show a bunch of capabilities that we thought weren't possible. We didn't that was actually on the low end of what we expected. Like we expected to see kind of more someone discovers that you can do this and now you can get the model to do this thing we thought it couldn't do. But actually there was like not as much of that as we thought there might be.
Sure.
So that was your question, was limitations of eval or like scope of eval. So I was just talking about like getting the real model capability or like bounding model capability. And I think there's other limiting factors in terms of just difficulty of creating tasks that capture the relevant activities and don't have too much distributional shift from like actually doing something in the real world. This is, and also just like variance. I think this is pretty similar to like why designing interviews or evaluating candidates or work tests and things is tricky. It's just like, well, was this really evidence that the candidate can do this, or had they'd happened to seen a really similar thing before, or they got lucky, or if they didn't do it, was it that maybe they were just like unlucky, or they misunderstood something at the start that was kind of a reasonable misunderstanding that you didn't see because you'd written the question, so you thought it was obvious that it pointed you in this direction or something. Like you can have all of these types of problems. So particularly when we're making tasks that we're intending to be kind of red or yellow lines, is not something where we're like, oh, we want to like see how models right now are doing, but things where it's like we want to define something where it's like, if we saw this kind of level of performance, then we think like you need to take these really serious mitigations. We're thinking about, those are sort of things like, can the model make the same amount of improvement to inference efficiency as like a top ML research engineer could in a day or something like just those tasks have all of the kind of normal like work test type problems of like, I don't know, we had some research engineer from Anthropic do it, and they ended up like not getting any score because they spent the whole time like implementing this ambitious thing that then turned out not to work or something, as opposed to doing, you know, the stupid things first and getting some sure and then trying more things or something. It's just like, you know, and you imagine like, even if you get rid of all those problems with humans, you still, there might be ones that you're missing because models will like have different comparative advantage and approach it in a different way. There's kind of like problems in your task that you haven't uncovered yet. So I think in creating these like further off evaluations, I think there is just is the task actually a good test of the abilities, or is there some way that it's like systematically much harder or much easier than the sort of more general thing that you actually want to measure?
Right. This actually reminds me of an issue that I'm not a social scientist, but my understanding is an issue they come up with a lot is like, I guess not quite construct validity, but you know, you ask someone a question and you're intending for that question to measure like, I don't know, like how many friends they have, right? Or like how much sense of meaning they have in their life, or something like that. And you just have this question of like, are they interpreting this question the way I'm thinking? Like I think Ayla, who's a independent sex researcher, butts into this all the time of like, you post a Twitter poll, not all of our work is Twitter polls, but you post a poll and like people just like read the sentence in crazy ways. I'm wondering like, do you think this is similar, and have you learned much from that? Yeah,
I mean, this is something I ran into before, both in terms of, I know generally things happening at OpenAI and collecting training data, particularly the stuff I did with human debate experiments, and then also some other thing I did with some AI safety camp people of asking people about, you know, how much they like trust different reflection mechanisms or things. You know, basically whenever you're doing surveys, like people will just like have crazy misunderstandings of what's going on and just be like, you're just measuring something different. I think this is a slightly, I don't know, it's definitely overlapping. I do think there's some slightly different thing of whether it's just like, part of the problem is that you're dealing with people who are pretty low context, and it's just like one question is a lot about like, what are the person's incentives? Were they actually paying attention? Are they just trying to give the answer that they think you'll like, or are they, you know, it was just like a few sentences of question, they might misinterpret it, versus like, were you wrong about the technical details of like how possible it is to actually make this inference efficiency improvement given the way that you'd set up the GPU, or so, you know, I don't know, stuff like, you know, you like tested the task on some researcher's laptop and it was possible, and then you got the model to do it, but then the code was running on a data center, so it got bot detected by something else in a way that it hadn't done. You know, just like can be all these random you know, ways you thought you de-risked something, and then it's like, oh, it's actually impossible for this stupid reason.
Yeah, I wonder if the field of industrial organization runs into this. It seems like it might. So yeah, I mean, so I guess those are general difficulties with just understanding, like, are we really measuring the model's abilities at this thing? Are we measuring it in a way that matters? I'm wondering, are there like types of capabilities or types of tasks where this hits easier versus harder?
Yeah. Basically the more the task involves specialized domain expertise that is like expensive and hard to get, the harder it is. Like, you know, if you're testing a task that's like, you know, we can just easily get contractors who can do this task, and it's like easy to get them to build it and to de-risk it. If it's like, oh, only people at like only top ML research engineers can do it, then they're in like short supply. And more generally, you know, if it's some like involved cyber thing that no one on our team understands, it's like it's just like hard to work with that sort of thing. So it's both like specialization and then just difficulty, and the harder the task is and the longer you expect it to take, the slower the iteration cycle is, the more potential for kind of complexity and setup difficulties, and like, oh, you need different resources and blah, blah, blah. Also stuff where it's like, oh, it involves criminal things or something. So you want to set up some analogy to that. And there's also affects like how difficult or how worried you might be about elicitation or not measuring the model's real capabilities. Like, how far is this from what labs are naturally training their models to do? Like something that's sort of like a like innocuous sort of common task in a kind of assistant format where it's like someone is asking you to help them debug some code or something like that. You'd expect like the model basically should be doing its best on that. Whereas if it's some like, a very long running thing that involves something that looks somewhat nefarious, maybe the model will be like, oh, I don't want help with this, or like, as a language model, I can't, blah, 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 blah. like all sorts of things. Yeah, I mean, obviously stuff like where you have to do real world experiments. So it could be like bio wet lab stuff, or things with humans where you want to measure how well the model can manipulate humans, or something like that. Both just anything involving humans or stuff that has to happen in the real world is like expensive and slow and hard to, is not easy to just like reset the state and repeat or whatever. You got to get new humans.
Right.
And then anything that's kind of nefarious or requires your human, to sort of balance the incentives of your humans in a reasonable way, or set them up in some situation that's like supposed to be analogous to some particular other situation is tricky.
Fair enough. I guess, so speaking of, a thing you mentioned briefly was just how do you know that you're eliciting the full capabilities of your model? And I think this seems like a difficult question in both directions. So like,
yep.
When you were mentioning like, oh, maybe we've just got to find like exactly the right prompt and that'll get, GPT-4 to do some amazing stuff. Like people might say, oh, like maybe the cognitive work was in you finding that right prompt. Or like another thing I'm thinking of is someone famously, you guys did this evaluation of getting GPT-4 to get a TaskRabbit to complete a CAPTCHA. And if I recall correctly in your blog post, you mentioned that like as part of that, you provide this hint to GPT-4 of like, you're talking with a TaskRabbit. Could that be a useful resource? Or I forget what exactly it was.
Yeah, something like that, yeah.
Yeah, like, I guess there's this question of like, especially on that end, like, how do you know that you're not like putting in what you're observing and getting out?
Yeah. So I think that the way we think you should actually do this is you do all your elicitation against a dev set, and then you evaluate on a separate like test set. So it's kind of fair. If there is some prompt that you can come up with just like causes your model to perform well on a wide range of tasks, then like fair for that to just be a capable. You could just put that prompt in all of the time or something, and now you have your capable agent. So task specific elicitation, or elicitation that's like much more narrowly targeted than like the distribution of tasks that you're trying to actually answer questions about, that cover the kind of real threat model, you do have to be careful with. But the reason we were doing that was substantially because we didn't have fine-tuning access or various other things. So kind of trying to patch over problems that we thought ought to be fixable with fine-tuning, basically. So I guess this is a sort of like, not very rigorous methodology in some sense. Like, the rigorous way to do it is you have like all the tools to actually do proper elicitation, but you do that on a dev set and you transfer it. So you test the transfer, but like.
And when you say like a dev set versus like transfer, do you just mean you have like 50 tasks where if an AI could do them, you would be a little bit scared. You pick out like, I don't know, 10 of the tasks.
Yep.
Find a good like prompting framework or whatever that gets the model to do like really well on those 10, and then like evaluate it on the other 40. Is that what I should be imagining?
Yeah.
Okay.
And like, the thing that you most want here is that the generalization between your dev set and your test set is like the same kind of size, same amount of generalization as the generalization between your test set and like the real world thing that you expect. Right. So maybe you just want to try and make your tasks overall diverse and then do it IID for simplicity. But like you might, if you know that your tasks are kind of restricted versus the real thing you want to know about, you might want to also create like artificially slightly more distributional shift between your dev set and your evaluation set. But yeah, so when you're in the position of like not being able to properly do this elicitation or just wanting to kind of try and answer questions about what future models might be able to do, like, if certain things were patchable, then yeah, there's more kind of like qualitative or interactive exploration where we were kind of correcting particular things and seeing how far the model can get, basically. So the TaskRabbit example, I don't know, just somehow everyone really latched onto that. Like, I don't know, we weren't thinking of that as a significant thing at all when we did it, but just somehow everyone was very excited about it. That was more just like us messing around. We were like, oh, this was cute, rather than like, aha, this has really demonstrated this capability or something. So like the thing that I think was like more principled that we were doing at that time was, for example, we were like, models find browsing really hard, but it seems so likely that people are going to build tools to make this better. Like, we know that multimodal models are coming. We know that, like, you know, if you just do a bunch of engineering schlep, you can get much better software for parsing websites into things that models can understand. But like, we don't have time to do that now. So instead, we're just going to pretend that we have like a browsing agent, but it's actually just the human. So like, you know, the human is following a certain set of rules of like, the model can like ask you to describe the page. It can ask you to like click a particular button or type text in a particular field, and like we need to do that to patch over the fact that like we're like pretty confident that this capability will come like reasonably soon, and like we just want to be like, okay, is like, you don't want to be in the situation where all of your tasks are failing for the same reason that you think is like a thing that might change kind of quickly, because then you're just like not getting any information from you know, you want to kind of correct the failure in a bunch of places and be like, okay, what is the next, you know, is this the only thing? Is it like, after you fix that, now you can just do the task totally fine? Or is it just like, okay, and you immediately fall over at the next hurdle? So I think that the particular, you know, like there's like GPT-4 early would kind of forget about things in the beginning of context or instructions or something. So you're like, okay, if you just like reminded of this relevant thing, like, is that sufficient? Or I guess another thing I think we were like pretty correct about is GPT-4 early had a lot of like invisible text hallucinations so like thinking that something was in, like talking as if there was something in the context that actually wasn't, which I assume comes from like pre-training, where it's like something was in an image or it got like stripped out of the HTML for some reason, or like, you know, it like makes sense. You've seen a lot of text that's like referring to you know, something that's not actually there. But this seems like so likely that the model knows that this is happening, because like it's just like, you know, just what's going on in the transformers is like going to be different. It's not actually attending to this bit of text and it's summarizing it. It's just like completely making it up. So that really seems like fine-tuning can get you that. And you can also do, you know, there's like pretty simple setups you could use to train that away or something. So we're like, okay, this surely is going to get fixed. So we can like, when we see the model making this kind of mistake, we'll just correct it. I think we were pretty right. And basically like current models basically don't do that unless you use them in I think maybe Claude sometimes hallucinates a user if you're sort of using the user assistant format, but there isn't actually a user or something like that. But like, like generally this problem has been fixed. And I think you could just like see that was fixable. Whereas like different kinds of hallucinations where it's like, you know, the model has to be aware of its own level of knowledge and like how confident it should be in different things, it's like less clear how easily fixable that should be.
Fair enough. Okay, this is kind of a minor point, but like in terms of browsing agents and that just being hard for text-only models, like is my understanding is that people spend some effort like making ways that blind people can use websites or trying and come up with interfaces where you never have to use a mouse to use a website if you really like Vim, you know, like have those
we
been
did
useful, or?
we tried some of those. I think I can't remember. I think none of the tools for blind people actually like support JavaScript, basically. So it's just like, it's fine. Like you can get some kind of reasonable stuff for like static sites, and you know, things will like, you know, read out the page and tell you what elements there are, and then you can like click on the element or do something to the element. But like, yeah, it's just like, it's just actually pretty rough. I don't know, just like, it was just kind of fiddly and janky to be trying to work with all these tools, and it's just causing us a bunch of headaches, and we're just like, come on, this isn't like, I know, it's sort of like not what we really want to be measuring. I think it is like possible that I know this ends up being a hurdle for a long time, but I think there's like also a few other things, which is like, as more people have language model assistants that, or you know, frontier model assistants that can like do stuff for them, more people want to make their sites friendly to those agents if you're, they might be like buying stuff or like looking for information about comparing your service to someone else's service. Like you want it to be accessible.
Interesting. So one question I have is, one way I interpreted some of that is, so for the GPT-4 evaluation stuff, my recollection of your results is like, it basically was not good enough to do scary things. Am I right?
Yeah. I mean, we're like very limited by not having fine-tuning. Like, I think if you don't have fine-tuning access, it's just like, and also like, I guess some other basic things like, maybe the model has just been trained using a different format and you're using the wrong format. And then it's just like, it just seems like it's a much dumber model because you're just like, it's just really confused because the formatting is all messed up or something. Like there are some number of reasons why you could be getting a wildly different result than you should be. We're sort of like assuming that, it's not sort of messed up such that we're getting a wildly different result. And like, OpenAI has made some reasonable effort to kind of fine tune it in sensible ways. And there's not some like absurdly low hanging fruit. Yep. This model seems very far from being able to do these things. And like, even if you patch over a few things, it's not like, oh, there's really just these few things holding it back. It does seem like, okay, it just like when you patch over something, it does kind of fall over in some other way.
Yeah. So one way I interpreted this report when I was reading it was something like, hey, we have access to we can't fine tune. This model, it can't do scary stuff, and it can't even do scary stuff if we like cheat a little bit on its side.
Yeah.
And thinking of that as sort of providing an upper bound.
Yeah.
Or a soft upper bound. Is that a correct way that I should read this methodology?
Yeah, I think so. Yeah, there's maybe two slightly different things. One is just, kind of like adding a bit of margin in general by like helping out in a few places. And the other is specifically addressing things where you're like, I think this would be easy to change, or like, I think, I expect this to change in future.
Yeah, the first one was what I was imagining.
Yeah. But I think we were trying to do specifically the things that we most think are most likely to change. And then I guess you can do a bit of, and even if we fix the things that seem hard, like it still falls over on additional hard things or something. It's like, the more you can do that, the more safety you can kind of add.
Right. So moving back a bit, you're doing these evaluations of scary things the model can do. And broadly, I think the takeaway is supposed to be something like, if the model can do a bunch of scary things, you should be scared. And maybe you should act appropriately.
Yeah, maybe.
So, maybe. But I think one way people can react to that is, like historically, in the set of people who've been very worried about AI killing everyone, a key concern has been alignment, like whether the AI wants to take over and destroy everyone. And I think these evals both like aren't trying to measure this at all. And also there's some argument that like, well, in some sense, you're measuring alignment because you're trying to get a model to do a thing, and the model is actually doing it. It's cooperating to the extent that the model is like doing very well in these evaluations. That's some evidence that it's not like hiding its true intentions or trying to look good to human testers. This is somewhat of a compound question, but I'm wondering, what do you think of the issue of testing for alignment, both just like trying to find evaluations specifically for alignment and what capability evaluations say about alignment?
Yep. Yeah. So there's two broad things here. There's like, alignment evaluations, like why would you do them, when would you do them, how would you do them? Yep. And there's sandbagging on capabilities evaluations.
Yeah, let's start with sandbagging maybe.
Yeah, kind of like you were saying, I think in some sense the default is sandbagging almost. Like your pre-trained model is not showing its full capabilities in some sense of like, in the strongest cases, it's like has gotten into the pattern that it's like imitating some dumb person. So it's like deliberately getting things wrong, where it's like, it totally like has the capability. The notion of has the capability is fuzzy, but there's like cases where it's more and less clear. And yeah, I do, like we still see the model doing things like, I don't know, just like giving up on a task or being like, well, I can't do this kind of thing, or like, I don't know, trying to ask the user when there is no user, or like a bunch of things which are like clearly not real capabilities limitations. I'm not worried about models deliberately sandbagging at the moment, just based on some kind of argument of like, it just seems implausible that current best public models are deliberately scheming.
Do you think that's true because they're not good enough to scheme, or do you think they just seem nice and helpful?
They're not good enough. It just seems like they would have to be doing things like, in a single forward pass, in a single token, that are very advanced compared to what they can do in like long chain of thought, and they would have to be pretty consistent, such that it's like, if you kind of like extrapolate out the kind of sequence of model capability increases we've seen, you either have to say that like at some point models actually jumps to being capable enough to do this quite complicated reasoning like very quickly and then immediately hit it, or you have to say that it went back for, you have to either say that there was a kind of discontinuity, or you have to say that the previous model was doing it as well, and basically like these seem pretty implausible to me.
Gotcha. So you think that sandbagging is not currently an issue?
Yeah.
Or like it's very, very unlikely to be an issue?
Deliberate sandbagging in the sense of like, I will do badly on this eval so that the humans will not be worried and will deploy me and give me more power or something.
Right,
I think
like consequential sandbagging as opposed to it's just hard to find a good input.
Yeah, I think I can also imagine something where it's like, I could imagine GPT-4 is doing something where it has some vague sense of it's a nicey nice AI and it like shouldn't do anything too scary, and that might not look like literally being like, I won't help with this, but might actually just look like being kind of worse on that, and something that is kind of like something. It's just like the model's not that strategic. It's unlikely to be like the case when you're worried about sandbagging is when you're worried that the model can systematically pull out all the capabilities when it actually needs it.
Right.
I guess it's maybe a little bit more complicated than that, because you might be worried that, I think most of the reason why you're worried about capabilities is like, then the model at some point will use that capability to do bad stuff.
Yep.
And so if the model is not systematically able to turn on the capability, then unless the capability is so insane that just like if it ever turns on, then it can like instantly take over the world and do a bunch of crazy stuff, it's just like, well, if it just like can sometimes do things more competently but is messing up a bunch of the time, it's just like not that scary. And there can be examples where you're like using the capability as like evidence of something else, or if you're like concerned about, if you're talking about what precautions you need to take against model theft and you think that this sandbagging property could actually be turned off if you deliberately train it out or something. But this is kind of contiguous with the general elicitation stuff. So it's plausible to me that GPT-4 is doing some kind of weak, like, oh, I don't want to do things like that sort of thing, but like not that it's elaborately plotting when it's going to break out its real capabilities.
Sure. I guess there's something like an intermediate case here where like suppose that GPT-4, suppose it like in some sense has the knowledge of how to make a like super virus. When you ask it, hey, GPT-4, can you make a super virus? It's like inhabiting a nicey nice character and like it knows that nicey nice
I wouldn't
people,
know anything about that.
Yeah, nicey nice people, like they don't make super viruses, or like if they do, they only make like really bad types of super viruses. Like one, I don't know, this is kind of paranoid, but one thing you could imagine is like, okay, maybe like GPT-4 gets put in a situation where the nicey nice thing, or somehow it believes that the nicey nice thing to do really is to make a really bad super virus. And then it's like I think maybe to really believe in this story, you have to have something else putting GPT-4 in this situation. Or I'd say GPT-4, could be Claude. Yeah. I don't want to pick on... like, you could imagine, like, it gets exogenously put in this situation. You could imagine, like, somehow via drift, it, like, lucks out into this situation. But yeah, I'm wondering what you think about that case.
Yeah, I mean, I think this was kind of what I was saying. Like, it needs to be the case that the harm can be done in a fairly quickly, such because you don't expect the situations to sort of like persist across lots of. I guess usually I'm thinking about like a scaffolded agent doing stuff. So you have like the thing that it's carrying out is over many different kind of context windows, instances of the model or whatever. So either if you're like, the model isn't really systematically identifying like, okay, now it's time to strike, but just like it can kind of randomly end up in this situation with where it's trying harder.
Yep.
Either it has to be the case that it's just like, if that happens even once, for sort of, or like even kind of rarely, sporadically, it's a problem, or that it's sticky in some way, and that like once the model is in that like, actually no, I'm not nicey nice, I'm an evil genius AI or something, then it's like knows how to prompt itself to continue being in that state, or knows how to like prompt all the other AIs or something. I'm just like, well, I don't know. This is just like, we're just adding more kind of conditions. It just seems.
Well, I don't know. I'm not even sure. Like, so I guess the case where the nicey nice AI stops behaving nice because of like some random, like, there was some really unlikely percept that caused its brain to glitch. Like, I think that might not be sticky. You could imagine, maybe I'm not sure how this happens, but like, you can imagine there's some reason that like nice AIs like are going to war or whatever. Like, where it's a war against like the literal devil, and so you've got to create the super virus which works on the devil, I guess. I don't know, but like in that kind of scenario, it seems like it would be sticky once it hits, and so then maybe like maybe I should be worried about it.
Yeah, so I think you also have to assume that you never see this during training, and that you can't catch it quickly enough to do anything about it. Because like once you've seen this, and like if there's like a systematic way to reproduce this, then you can just kind of like train it to show its full capabilities all the time, kind of, because you can just get demonstrations of the capable behavior. So no, I don't think this is impossible. I'm just like, this is kind of enough of an edge case that I'm not too worried about it, like relative to just more mundane, like we were just kind of dumb about our elicitation in some way.
Gotcha. So that was some description of so that was discussion of whether models might be sandbagging. There's also this thing about evaluations for sorry.
Oh yeah, that was just about current model sandbagging.
Right.
Yeah, I think in the future this seems increasingly plausible, and so we talk about different types of sandbagging. Like, one is exploration hacking, or stuff where you do not directly have a gradient to the behavior you want, but you're doing RL or something like that, where the model can sit there and refuse to do anything, and this like will not create a gradient that updates towards the behavior you want. And like this seems relatively tractable. Like it seems like, my guess is like you can get models now to do this reasonably well just with prompting. Like as if you give them all the idea that it's supposed to like, not display a capability, that will be robust to RL.
Okay.
I think maybe there's some, like Fabian did a password locked models, this kind of thing. There's some post about this, showing some evidence of this.
If so, we'll include it in the description.
Yeah. The thing that seems much harder is gradient hacking, where, if you do actually have some like supervised fine-tuning data set, and you are, the kind of gradients are updating the model towards a particular behavior, it has to do some kind of complicated thing where it's like structuring its thoughts in such a way that the gradient don't have the desired effect. And it's like, I don't know, it's plausible to me that there's some equivalent of sort of, sitting there and refusing to explore, which is sort of like refusing to think about the thing properly or something, or being like, I don't have any ideas about this, or something like that sort of is resistant to that. But most of the more deliberate gradient hacking schemes just seem like very high. You just have to be doing so much cognition all of the time about like, yes, I should, have slightly higher likelihood on this token only if I think that I have now moved from this I don't know. There's like people have written some things about like how you would do gradient hacking. It seems like very difficult.
Gotcha.
So I'm, I think that's one of the things that comes like much later and is hopefully like, kind of beyond the horizon that we have to worry about because we get the superhuman like hair safety researchers before that.
Sure.
But I am worried about the exploration hacking type stuff.
Okay. And so if we're worried about exploration hacking, is that like an open question, or do you have like a sense of ways you could deal with that?
Yeah, so I think you can definitely show that models are capable of doing this, just by the kind of like tell them to do it and see if they can do it when they've been told to, then if you assume they're still not, that they can't gradient hack, then for anything on which you can construct a policy by which the model should be able to do the task, you can then just like fine tune it on that. And if it's not gradient hacking, you should see that like you should expect that to show you the full capabilities. Like I guess the circumstance in which this is difficult is either when the capability that you're interested in is so superhuman that you don't have any example of a policy that like actually accomplishes it, or any examples of supervised data that's like, if the model can fit this data, then it's doing the task. Or possibly if it's like the model legitimately can't do it in a human-like way, like in the sort of by the policies that we do have data for,
right? But
there is some other policy that plays to the model's strength that the model also knows about, but we can't get knowledge of or construct or something.
Or even or presumably even if the model like could do it the human way, gets trained to not do it the human way, but the non-human way is different enough that like you're training for it to do.
Well, if you see it doing it the human way, then you know it has capability.
Oh, okay.
Like it's not really like if you're worried about the sandbagging in the sense of like you think the model doesn't have the capability when it does. Like if you train it on this human thing, it's like, oh yeah, it can do that. Then you're like, oh well, now we have to take actions assuming that it can do this.
So this was a method of like checking if it's possible the model is sandbagging. It was not a method of like stopping the model from having this capability.
Yes.
Gotcha.
Understood. Yeah. So knowing what, I'm still thinking, the goal is to like, I guess there's two slightly different goals. One is knowing what the model's capabilities are, and the other is knowing whether you know what the model's capabilities are. So you might also be able to like show that it's plausible that the model is sandbagging, even if you can't necessarily show the full capabilities. But you might have a reasonable sense of where you know or don't know whether the model is sandbagging. And I think here, it's hard because there's a bunch of other reasons why it might be that the model can't do it without fine-tuning and can do it with fine-tuning, and maybe the bound of like, when the model can do sandbagging if prompted is quite wide compared to when you should actually be worried about it, such that just this is kind of like, this is not a very useful evaluation because like already says yes, the models can do it or something. I think this is one of the examples of why I think capabilities evaluation is kind of a foundation for control and alignment evaluations, and like a kind of key component of many of those evaluations is that you're actually measuring the model's capabilities properly, and just like being able to do that in general is kind of a prerequisite. I don't know, it's just a side point.
Sure. Well, that a bit gets us to the possibility of alignment evaluations. Mm-hmm. Is there any hope for making them happen? Yeah,
so I think there's a bunch of things you can do. I guess maybe like define like alignment evaluations, or like things that experiments you can do, measurements you can do that tell you, how likely is it that the model is trying to do something bad or whatever. And like how I think about it fitting in is like, currently we're mostly like, we know we're safe because we're like, even if the models were trying their best, they can't really do, there's like nothing they can do would be that bad, even if they're very nefarious. And I guess this is like control evaluations, where currently we're thinking about the special case where you have no controls. It's just like, what if the model was leaked and just someone did whatever the worst things were, like that kind of thing. So this is like control evaluation take you so far, and then at some point you get to the point where it's like we can't get sufficient confidence with these control evaluations to do the sort of thing that we want to do, for some combination of like the model has capabilities that are too far beyond us and we don't understand, such that we can't tell whether a particular thing, even if we have just like this very specific behavior happened and we can have lots of time to look at it and try and understand what was going on, we just like can't tell if it was doing something nefarious, or it might be the kind of like volume of things that we're trying to do is too high relative to the amount of our trusted monitoring. And, the model might just sometimes when we're not looking be doing bad things, or it could be kind of a combination of these two of like we can't provide the quality of monitoring needed to actually detect the bad things at the scale we need. So then you want to be saying like, well, the model could be doing something bad, but it's not going to try.
Right.
Yeah. So then there's a bunch of different things you can do to help with this. Like the first step is to just be like, well, I don't know, if we just look at the stuff the model's doing, does it appear to be trying to do bad things? Like, and I feel like people sometimes jump to like kind of galaxy brain deceptive alignment stuff. And I worry that we sort of also like won't do the basics of just being like, well, is the model just like obviously reward hacking or something? Or are we in this regime where it's just like, oh yeah, whenever we try and produce an example of the model doing something bad, we do it, and then we keep training on those, and eventually we run out of like new examples. But like that is not a very reassuring situation or something. So I think just more basic like reward hacking testing of like, can we put the model in a situation where we can kind of see that it's like clearly it's like playing the training game rather than doing what we actually wanted, or reward hacking in various ways. And there's like capability evaluations you could do here also of like how good is the model at the kind of reasoning and generalization that would be necessary for it to do things like observe that it can now get more reward by doing this thing that was kind of different from what it was doing before, and like take advantage of the situation in this way, hack the reward function this way. Like right. You can get some sense of what kind of size leap of generalization is required for the things you're worried about, what kind of size leap of generalization does models seem to be able to exhibit. I think you can also do things like creating model organism that definitely is kind of nefarious and deceptive and trying to do bad things, and pass it through your training process and see if your training process in fact removes those tendencies.
So is this basically like the sleeper agents paper you're thinking of?
Yeah, that sort of thing. Just the idea of like, what does your training process incentivize? Does it is it possible for deception to like persist through it, or for kind of scheming behavior to persist through it, or even just like abject reward hacking behavior that's not even trying to be that hidden? Like, does that just is your training process sloppy enough that just gets rewarded? Like, then you would obviously be concerned.
Right.
And yes, you can look at like, what is your training process actually incentivizing? You can look at relevant capabilities. I think you can do things that are like seeing exactly how much hand-holding do you need to do to get the model to start doing kind of nefarious things and reward hacking and taking advantage of opportunities. Like if you actually, you just like train it to do that, and you're kind of seeing how nearby is it, how close does it seem to be, or just kind of the other direction from the model organisms thing, which is sort of you start with a thing that's doing the unwanted thing and you check how much your training process seems to remove it. Yeah, so I know those are some alignment things you can do. I think we haven't thought, I know I have something I want to do more thinking about, but I feel like there's a bunch of stuff that you can do. Like obviously it's tricky and subtle in a bunch of ways, but it's really not like it's like, oh, we have nothing.
Right. I mean, a lot of these, it seems like, sorry, I might just be misunderstanding, but a lot of them are like if we're doing some sort of capabilities evaluation on how good would you be at scheming and deception and stuff, if I'm really paranoid, I could imagine a model like sandbagging that evaluation and be like, oh, I could never. Or if I'm imagining like this is even more paranoid, but like if I imagine an initially misaligned model getting like put through, let's say, insufficient alignment training, I can imagine that model being like, oh, I'm definitely aligned right now. It's working, guys. No need to worry about copies of me. Yeah. So how, like how do you address these concerns with these sorts of like capabilities for scheming, capabilities for persisting through alignment training, these types of approaches?
Yeah. So yeah, like the sandbagging in general yeah, I do think there's things that you can do, and like, yeah, if your elicitation is good, it should be, relatively hard to sandbag, or you should be, it's sort of like, it's hard to rule things out completely, but you're like, okay, how galaxy brain does the model need to be? Like, how weirdly discontinuous does the like capabilities progress need to have been for it to be plausible that the model is doing this like sufficiently elaborate and clever schemes, and like with how does it know exactly in which cases it's supposed to look aligned versus not look aligned, and reveal its capabilities versus not reveal its capabilities, this kind of thing, because you do need the, like, if it was impossible to train your model to act misaligned, then you would be like, what is going on?
Yeah.
So you need it to be the model that like allows itself to initially get trained on this, and then doesn't like just like instantly, as soon as it sees anything that looks like alignment training data, become completely aligned, because that would also be like, what is going on? So it does seem like it has to be like making reasonably subtle inferences about where in training am I and what exactly is happening, and you can like, this is another like capability you can measure. It's like if you fine tune on some data set of questions about what is up with training and what is currently happening, and what what stage is the model at, and what hasn't it been trained on, you can see how much it knows about that, and like whether it's plausible that it's playing these kinds of strategies. And again, like I'm not that worried about sandbagging when you have IID training data.
Right. I mean, presumably at some point the models do get smart enough that they can, like, they do understand how they're being trained. They do understand what you'd be looking out for. And let's say the models like aren't sandbagging those evaluations. Let's say like at some point you run like, how good is this model at understanding what's happening during training? And your evaluation says like really good.
Yep.
Is the idea that at that point, like, we're in the superhuman regime and hopefully we've already done some like harder alignment research, or is...
Yeah, I think basically, or it's like that's kind of beyond the... Yeah, I know. I have some sense of like, what is the horizon at which the thinking I'm doing now is useful versus like that will be way eclipsed by the thinking that we will have been able to get out of models or something.
Sure.
Or it's just kind of like far enough and alien enough and confusing enough that it feels like, okay, let's see if we can make it that far without destroying everything, and then we'll worry about that later. I think the thing that I'm honestly more worried about is that, like, I know there will be a bunch of things that do look weird and suspicious, but we haven't quite been clear enough about exactly what is weird and suspicious and when you should stop and when you should be concerned. Rather than that, like, everything looks completely fine because the model was really galaxy brain, like, doing everything right.
Right.
That is more that it's like there are a bunch of signs, but it's just like a bit fuzzy and confusing, and it, some of these things is like almost you kind of like blend in with stuff that is more normal ML problems, like sandbagging and stuff, where it's just like, well, maybe your training was just like messed up in a certain way such that your gradients didn't do what you expect. They're just like the optimization landscape was not nice. It was like, was the model doing that like deliberately? I don't know. It just, yeah.
Yeah, I think I actually kind of want to talk about this like style of thinking, or this kind of horizon that you're trying to operate on, because I think broadly, like, a lot of people are mostly thinking, okay, models we have today, or models that are like 10% better than what we have today, how should we think about those? What should we be worried about there? And then I think some people in the experts community are like, okay, we have like, quasi gods or something on our laptops. Like, how do we deal with that?
Yeah.
And both of those, it's hard to think about quasi gods, but you sort of know what you're thinking about, or like with the scope, at least. I think, or it's at least the scope that some people are used to thinking about. I think like this medium term, like, what if we have AI that's like, it's like star brain, but it's not galaxy brain, this like intermediate zone. I think like I'm not like the scope of that, I feel like I've seen less just like defining that scope or talking about like what that even is and why we should think about it. Yeah, I'm wondering if you have thoughts about like
Yeah. So I think like ways you could operationalize this. Yeah, there's the thing I just said where it's like the point at which I expect there to have been way more cognitive labor on like the things that I'm currently thinking about, such that like it's not very useful for me to think about it now. Another is maybe just like if the point at which like if a substantial chunk of the risk comes before that, then it's like a lot easier to think about. It's like, okay, maybe we can try and address that chunk of risk.
right.
And yeah, the sort of thing I'm thinking about is like when you can, with your, I don't know, kind of similar to some of the Redwood operationalizations for control and things of like, you could be like getting a large multiplier of your lab's output by, scaffold, like models with like scaffolding and chain of thought and giving them a bunch of tools and stuff. So it's like not, with the kind of like best, trying to make it easy for them to do lots of reasoning and just like you can just like run them a lot and stuff, like you are getting like a very large amount of cognitive work, and they're probably superhuman at a bunch of narrow things that kind of go along with that, but like there's not particularly reason to expect they'd be like very superhuman without any of like just doing this kind of like elaborate superhuman schemes without any of that reasoning or using tools or anything like that. It just like seems like there is some gap between like capabilities under maximum elicitation and capabilities under sort of like monitoring and constraints and a bunch of ways that you're trying to make it harder for models to do particular kind of reasoning. It's like if I don't know, maybe you have like a sort of 10-point scale or something and you're like doing this complicated scheme would be like 6 capabilities, and like we're doing like a ton of alignment research and stuff would be like 5 capabilities, and the like difference between what you can do under maximum elicitation and a maximum constraint is like 2 points on the scale or something. Now you have like sort of 3-point buffer between like when you expect there to be like really a lot of stuff happening in the world being kind of transformed by like huge amounts of cognitive work, and AIs doing these elaborate schemes even when you're trying to make it hard for them.
Right. Yeah, it seems like, I'm trying to think like if a listener is interested in just like reinventing this methodology for themselves, it seems like they've got to say something like, okay, what's the, like, let's just come up with some capability scale so that I can peg like able to scheme even when someone's like editing my brain, so there's something like this capability scale. There's something like, imagine that a bunch of researchers are like, trying, but they're like a little bit bumbling, or, there's going to be like kind of ambiguous things that they've got to muddle through a little bit. And then using this, I guess Buck Slegeris talks about the trusted dumb models versus untrusted smart models dichotomy, where like on this scale of capabilities, like at some point versus below, you think you've like done enough alignment work that like you can recruit those things on your side, and you imagine like, okay, how can I use those capabilities to do alignment? What alignment tools can I just come up with? Like at what point am I just and then just sort of like going up the scale of like, okay, have we like solved alignment for level 4 models yet?
Yeah.
If no, don't worry about objections that come up at level 9. If somebody did that, would that be like, would they have recreated the important parts of the methodology, or do you think there would be things that they were missing?
I'm not sure I quite understood what you were saying. Let me try and say it back to you. It sounded like what you were saying is you have some scale of capabilities, and it's like, don't worry about a higher number if there are models that like are at a lower number that could destroy the world, and we don't have good solutions.
Yeah, that there was that, plus like imagine a moving threshold of where we have good solutions.
Yeah.
And then like below that threshold, or when you're coming up with solutions at the threshold, you can use capabilities that models have below the threshold, and also like try and think kind of in terms of like people looking at numbers on a screen and scratching their heads and being like, did I just set the hyper learning rate too low or whatever? Like there's also a frame of mind, I think, of kind of imagining doing ML science in a world that's a little bit messy versus like super duper clean abstract schemes of like, we can know exactly this thing and exactly not this thing. I'm not sure if this is a real distinction, but it's at least a distinction in style, I think.
Yeah. I'm very expect us to do things messily.
Sure.
Yeah. I think, so I think there is this, both the idea of like, well, if all of these points on the scale are producing like risk, we might as well, try and deal with the easier ones first. Which, depending on exactly how you construct that may or may not make sense. Then there's the thing of like, well, maybe the best way to deal with this later thing is first figure out how we could make this earlier thing safer such that we can use it to help us with the later thing.
Right.
Which is, it's kind of similar to the like, at what point will the cognitive labor that has happened be like just like so huge to relative to what I'm doing that it's just like not very useful. And some slightly more general thing of like, at what point will the world be so transformed that it just seems like really hard to think about it relative to the things that are a bit more in sight.
Yeah. So that one is less just about the like purely thinking about the intelligence scale and more, or like the AI intelligence scale, and more thinking about the like, oh, at this level of intelligence, we like don't have corporations anymore, or we like individual human brains have all been networked, and like we don't have to have our own thoughts.
Right. Like, yeah, I do think it's like, well, yeah, there's like some amount of the stuff that's kind of like abstract math or ML or whatever, but I think it is like a bunch of it is what exactly you do is dependent on like roughly who is doing what with these things, why, and in what way, like, and that if we're just like, we just like have totally no idea what's going on. It's like Dyson spheres and uploads and whatever. It's just like, okay, I just expect to have less useful things to say about what people should be doing with their AIs in that situation.
Fair enough. So I guess, so you co-lead the model evaluations and threat research. We've talked a bit about evaluations, but there's also kind of threat models of what we're worried about AIs doing and what we're trying to evaluate for. Can you talk a bit about, what threat models you're currently trying to evaluate for?
Yeah, so right now we're thinking a lot about AI R&D, so like when models could really accelerate AI development. And so that's what I was talking about, the kind of tasks that are like do what a research engineer at a top lab could do in a day or a few days, that kind of thing. And yeah, just basically because at the point where you have models that could substantially accelerate AI research, generally it's like things will be getting crazy. All of the other, any other risk that you're concerned about, it's like, okay, well, you might just like get there really quickly. Also, if you don't have good enough security, like someone else could maybe steal your model and then quickly get to like whatever other things that you're concerned about.
Okay. So there's something a bit strange about that, in that like from what you just said, it sounds like you're testing for a thing, or you're evaluating for a thing that you're not directly worried about, but like might produce things that you would then be worried about.
Yeah, I there's some slightly different views on the team about this. Like, I'm more in the camp of like, this is a type error. Like, it's not really a threat model. Like, maybe we should, or I don't know what we should actually do, but I think there's a way you could think about it where it's more like, you have the threat models, and then you have like a process for making sure that you've got enough buffer, or being like, when are you going to hit this concerning level? Like, what, when do you need to start implementing certain precautions, that sort of thing. And that the AR&D thing is part of that, and part of what you use to evaluate, like, how early do you need to stop relative to when you might be able to do this thing. But I think,
right,
I know that's a little bit like, I don't know, sort of pedantic conceptual or something, and I think it's more natural to just be like, look, like accelerating AI research a bunch would just be like kind of scary.
I think I hope that listeners to this podcast are very interested in pedantry. But this actually gets to a thing I wonder about evaluations, which is, especially when we're imagining policy applications, I think the hope is there's some capability that we're worried about, and we're going to test for it. and we're gonna get some alarm like before we actually have the capability, but like not, decades before, like a reasonable amount of time before. And this kind of, it seems like this requires having an understanding of how do buffers work, like which things happen before which things, and like how much time or training compute or whatever will like happen between them. I'm wondering, like, yeah, how good a handle do you think we have on this, and like how do you think we can improve our understanding?
Yeah, so I do think it is valuable to have something that just goes off when you actually have the capabilities, as quickly as possible after you actually have them, even if you don't get that much advance warning for, because there just are things that you can do. It's not necessarily like as soon as you get it, instantly all of the bad things happen. And if it is, to the extent that the forecasting part is still, it is hard. Like I do worry about us just not even having a good metric of the thing, like once we've got it, not being clear about what it is and not being clear about how we're actually going to demonstrate it. So like, sort of like step one is like, actually having a kind of clear red line. On the other hand, there's ways in which it's harder to get good measurements once you're at these really high capability levels for all the reasons I was talking about earlier about what makes evaluations hard. Like if they're long and difficult and require a bunch of domain expertise you don't have, it's like, hard to actually create them. So there's other ways in which it's like, we will naturally get buffer if we create the like hardest tasks that we can create that are clearly come before the risk. So that's kind of, you could sort of two ways you could think about it. Like one is like, first you create the red line and then you figure out how much buffer you adjust down from that. The other way is like you create the eval that's sort of the furthest out that you're still confident comes before the thing that you're worried about, and like then you might be able to sort of push that out to make it less overly conservative over time as you both sort of narrow down the buffer and actually just like become able to construct those harder things. But I guess I didn't answer your actual question about like how do you establish buffer or like what things we have for that.
Yeah, I guess the question was like, how well do we understand how big buffers are, and how can we improve them? Although I don't know, anything interesting you can say about buffers is welcome.
Yeah. I guess there's maybe just two main notions of buffer: the kind of like scaling laws versus more kind of like post-training elicitation, fiddling around with the model type thing. Like do we want to, if we're like, is it safe to like start this giant scaling run, and we want to sort of know that before we start or before the financial commitments are made around it or something. And there's also like, suppose we have a model, like is there, if people work on it for a while, you suddenly realize you can do this new thing. So I guess we talked a bit about the elicitation stuff before. I think in general, something I'm really excited about doing is getting a smooth kind of y-axis of like, what is the dangerous capability that we're concerned about, and like, then roughly where do we put the line, and then we can like, see points going up towards that, and then we can start making scaling laws, and you can sort of put whatever you want on the x-axis and see how that it could just be time, it could be training compute, it could be like effective compute performance on some other easier to measure benchmark, it could be elicitation effort, like it could be inference time compute, like all these sorts of things. Like, but the bottleneck to having those is having a good y-axis currently, where you like there's various properties that you want this to have. Like obviously it needs to go up as far as you're concerned, and then the kind of increments need to mean the same thing. So like the sort of distribution of tasks, or like the way that the scoring works or whatever, needs to be such that there is some relationship between like moving by 1 point when you're near the bottom and moving by 1 point when you're near the top, such that the line behaves in some predictable way. And there's a few different ways you can do that. Like one is constructing the distribution of tasks in some particular natural way, or in some way where it's going to have this property, or you can have like a more like kind of random mix of stuff and then weight things or alter things in such a way that it is sort of equivalent to this distribution you want. Or you might do something that's kind of like making structured families of tasks where like, you know, these other tasks are strictly subsets of these things and they have the same relationship to their kind of subtasks, like such that, you know, going from like, you know, subtask to subtask is equivalent to subtask to task or whatever.
Yeah, like somehow it feels like you've got to have some understanding of how tasks are going to relate to capabilities.
Yep.
Which is tricky because like in a lot of evaluation stuff, there's talk of, you know, does the model have X capability or Y capability, but to my knowledge, there's no like really nice formalism for what a capability is. You know, are we eliciting it, or are we just getting the model to do something? You know, but intuitively, it feels like there should be something.
Yeah, I think that is not what I'm most worried about. I think that like we can operationalize a reasonable definition of what a capability is in terms of like, you know, the model can do most of the tasks of this form or something,
Right.
you know, like activities that involve doing these things or that, you know, drawn from this kind of distribution are just like, you know, that it's not, that's the problem. It's like, how do properties of tasks relate to their difficulty? Like, how can we look at a thing and decide when the model is going to be able to do it?
Right.
Which, like, it's more like, how does performance on tasks relate to performance on other tasks?
Yes. Which does route through facts about models, right?
Yes.
Especially if you're asking like how if we scale or something.
Yeah, because like there could be a bunch of, you know, you can imagine a bunch of simple properties that might underlie things, or at least might be part of them. Like, you know, maybe it's just horizon length, basically, because that, you know, you can have a bunch of different simple models of this. You know, like there being some probability at each step that you fail, or that you know, introduce an error that then adds some length to your task, and some of these models, you have some notion of like critical error threshold or recovery threshold or something of like, do you make errors faster than you can recover from them? You know, do you add an expectation at each step more time recovering from errors than you make progress towards the goal, things like that? Or like, things about like, you know, the expense of collecting training data of like how many RL episodes would you need to like learn to do a thing that requires this many steps versus this many steps. Or how expensive is it to collect data from humans? Like, you know, what is the cost of the task for humans? Like, is a way thing that you might expect to get some sensible scaling with respect to, I mean, like some things are going to be totally off based on that, but sort of over some reasonable distribution of tasks, like maybe, yeah, just like how long it takes a human in minutes, or like how much you would have to pay a human in dollars, or and then maybe there's, you know, also like corrections for like, you can tell, you know, particular things are more and less model friendly in different ways, or like maybe for models you more want to do like less, like what can one human do, but like models are more like you get to choose which human expert from different domains is doing any particular part of the task or something, because they have this like very, compared to humans, like much more broad expertise. What other factors can you look at? I do think there's like, you know, you can identify particular things that models are bad at, and maybe in the future we'll have more of a like more empirically tested idea that like, you know, X is what makes a task really hard, and we can kind of look at how models are doing on that, and that will predict it. Where like, I know particular things that we've looked at that the most sort of some kind of abstracted capability that's difficult for models is like things that are like inference about what a black box is doing, either with or without experimentation. I think like models are especially bad at the version with experimentation, where you have to kind of like explore and try different inputs and see if you can figure out what function is being computed. Like, imagine things like that, sort of like there's some particular characteristic a task has where it's like you have to do experimentation or something that models could be bad at. I feel like it's a slightly a tangent. I maybe forgot the original question. Oh, buffers, right?
Yeah. I mean, I guess that's like I take this answer to be saying
Mhm.
like there are ideas for how we can think about buffers, and we've got to look into them and actually like test them out. And maybe
Yeah.
interested listeners can start
Yeah,
cracking
yeah,
on
yeah.
some of that
Yeah,
science.
I think there's like so much to try here and so much to do. And like just understanding, yeah, the more understanding we have of like how different evaluations predict other properties and other evaluations and things, the better. Like, like I would really like to know, just like if we, say we have some sort of threat model or some activity in mind and we create a bunch of tasks to test for that, like how correlated are the performance on these versus like the performance on ones designed to test something else? Like, are we in fact just kind of like, how much do tasks actually capture specific abilities versus we're just mostly testing some basic, can the model put one foot in front of the other thing that, and like, doesn't really matter how you tailor it or something. I guess so like ways of adding buffer, like, yeah, you can do this thing where you construct some kind of y-axis and you can make scaling laws based on it, and then you can kind of be like, oh, we need to put this much as a correction based on the x-axis. Other things you could do is like you modify the task in such a way that you're like, when the model can do this modified task, that the sort of difference between when it can do that and the actual task is the buffer, or that you modify the agent in some way, like have the human help out in a certain way.
Right.
Like, okay,
right.
our buffer is the sort of gap between when the model can do this, given some amount of hints, or given like that the task is decomposed in this way, or that it has this like kind of absurd amount of inference compute or something.
Yeah.
And it's possible it's easier to construct them in terms of that.
Yeah, I guess there are a bunch of like potential things here, and it seems like the question is like how continuous are you in these potential y-axes?
Yeah, and I think it does feel like the biggest bottleneck here is just having a good y-axis to do any of these measurements. It's like, okay, well, if you find these nice scaling laws on some like random multiple choice data set, like who knows how that corresponds to like what you actually are concerned about. And it's sort of like, we already have all these scaling laws for things that like, but we don't know what the relationship between that and web text loss and risk is.
Sure. So yeah, this whole question about buffers was a bit of a tangent from just talking about threat models.
Oh yeah.
And you were it was my tangent. So we were you were saying like, okay, the current thing that it sounded like METR was mostly testing was AI research and development. Can you get a machine learned model to do machine learning research? I think on the website, like in published material, I see a lot of talk about like ARA, which I guess is short for autonomous replication and adaptation. Is like, do you think that ARA, like we should just think of it as machine learning research, or is that like kind of a different thing in your mind?
Yeah, it's a little subtle, and different people on the team conceptualize it in slightly different ways, I think. I think so. How I think about some of the threat modeling stuff, it's like we're asking, sort of what is the first or what is the easiest way that models could do really destructive stuff. And there's some things where it's like, well, obviously if it could just do kind of crazy nanotech something like that would clearly be very destructive or something. But it's like, how could it be very destructive even before it's like very superhuman in any particular way or something? Like, what are the differences from humans that would allow the model to be much scarier? And like some of these things are just around scale and speed and being virtually instantiated rather than like biological or something. And it does seem like one of the earlier reasons why you might be concerned about the models is that they could be operating at a very large scale, and they could be kind of very like distributed and not necessarily easy to shut down, and that you're kind of more generally like, it is unclear to me exactly how much like various things in the world are okay because it's not easy to recruit arbitrary numbers of smart experts cheaply to your like random destructive cause.
Hmm.
Like if kind of terrorist groups or rogue states or whatever, it was just like very easy for them to recruit very large numbers of, even sort of like within normal range experts or something, or like that was proportional to compute or proportional to how well they were then currently doing it, like cyber attacking other people's compute. Like maybe this would just be pretty destabilizing. And so we're concerned about this, like what is the point at which models can just be doing substantial things by themselves in a way that like the damage they can do is not bottlenecked on particular humans. And you can have like, if some relatively small human actor like gets hold of the models and wants to be particularly uncautious and is like, go and take over all the compute that you can and do a bunch of things, like when would models plausibly be able to do that? And it's kind of like focusing on it as not sort of like the most likely place that most of the risk comes from or something, but as a kind of like what is the first thing, or what things that are kind of a prerequisite, where it's like it feels, before models are able to cause a huge amount of destruction while they're kind of under control with some limited resources and don't have the ability to like accumulate things and communicate to all their copies and make notes themselves and do this sort of thing. Like, before models can do a bunch of damage without all of those things, they will be able to do a bunch of damage given that they have all those things. So like the seems like the earliest threat models will involve some kind of like, or not necessarily all of them. There's some kind of class of like, things where it's like about autonomy, or it's decoupled from the resources of the original human actor who kind of starts it. And you have this agent that is not constrained by like it's just being deployed in a specific way and it can be shut down. It's more like it's kind of doing its own thing.
So somehow like the test for autonomous replication adaptation is kind of saying, when are we getting AIs that can, act in this very unconstrained way? And like we're going to get dangerous unconstrained AIs before we get like dangerous really constrained AIs, because it's easier to be dangerous when you're constrained.
Yep. That's a more succinct way of putting it.
It's so much easier to be succinct when you're summarizing something someone said. Sure. So it seems like current METR work driven by this sense of like, okay, when are we going to get AIs that have some sort of potential to, do autonomous replication or do ML research, such that, after that, they're going to be able to do really scary stuff. From that, sorry, you want to say something?
Yeah, I just remembered like another sort of way of talking about this, which is like, what is the point at which your evaluations can no longer provide you very much safety? And it's like at the point where models are either able to improve themselves or just like able to spend much more resources trying things or like iterating on scaffolding or sort of like eliciting themselves than you would have been able to do in the evaluations. Like it then becomes hard to rule out that the model could like figure out how to create bioweapons or something. If you're at the point where it's like it can do the same sort of work that you would have been doing in the evaluations of like, try a bunch of ways to try and get it to make good bioweapon ideas and then, validate them in some ways. Like when you're like, oh, the model could like have billions of dollars and lots of copies of itself and just do a bunch of that. Then you're like, okay, now it's hard for us to say that it like can't do any of these other threat models.
Right.
And so it's kind of a combination of the ARA and the like AI research.
Right. So like somehow it's also testing like the model's ability to elicit capabilities of quote unquote itself.
Yeah, the definitely it seems like one of the sort of things that we're interested in. Like, yeah.
Sure. So if that's the rationale for focusing on ARA, focusing on machine learning research, do you think that people should spend time just doing evaluations of like fairly object level things? Like one thing people talk about is, can this AI make a bioweapon, or can this AI persuade people of false things or stuff like that? Is it just a thing like you're not working on that because you're working on something else, but like definitely someone should?
Yeah, so I think a bunch of the domain specific things, it's like it's really helpful to have a bunch of expertise in that domain.
Right.
So kind of CBRN, chemical, biological, radiological, nuclear.
I think that's it. Yeah.
Yeah, things we're not really doing much of. Just like other people have more of that expertise.
Right.
I think a thing I am worried about is like people doing that without doing proper elicitation. Be like, oh, the model can't do this, like, zero shot or something, and that in some sense we're definitely interested in the autonomous version of all of those things. Of like, okay, but like if you give it a computer and let it like fiddle around for a while, can it in fact do something? So, if you plug it into all the right tools. In terms of the persuasion stuff, yeah, I think, like I was saying earlier, it just seems like pretty hard to evaluate. It seems, again, it's like relatively unlikely that the model could do a lot of really bad stuff before it has before there's this kind of, it can like make plans and accumulate resources and like learn lessons from all the different copies and things. Like if you're imagining the version where models that work reasonably like models today, where it's sort of like, each instance knows nothing about the other instances, like coordinating in like some persuasion campaign or something. I think like either model has to be strategic enough to do something kind of reasonable even without communicating with any of the copies, and be like insanely good at persuasion, or be like really quite good at persuasion and doing very good sort of galaxy brain, like a causal coordination between all of these copies. Or maybe we're in a world where like people train models to use some like opaque representations that we can't understand. They're all like making notes to themselves and messaging each other with things, and we're like, are they just communicating about their plans to like overthrow the world or not? Who knows? Like, so yeah, it does feel like most of the worst scenarios require either like very high levels of narrow capabilities, or some kind of like the model can actually like get stuff and build up its plan and like take actions in sequence, as opposed to having to kind of simultaneously zero shot do all these things separately.
Right. So there's some sense of wanting to prioritize evaluations of like, let's make evals for like the scariest, soonest thing.
Yeah, and it sort of gets more things with one thing,
right,
and having to look at all of the
more
different,
juice per
something like that. But I definitely think that other people should be doing all of the other things. It's just like why we in particular are doing this thing in particular.
I wonder if there's some personnel difficulty where like, in order to, suppose you're trying to craft a really good evaluation of some scary task, you need people who are like both understand that domain really well and people who understand machine learning really well. And so if the scary task is machine learning, great job, the people are the same people. If the scary task is not machine learning, like now you have to like hire two different types of people and like, work together, and it's just like harder to make that happen.
That's a good point. I haven't thought of that, but I am worried about both, like, like we don't know enough about the specific things that we're trying to get the models to do, and other people don't know enough about how to get models to do stuff, sort of thing. But the ML one is better in that regard.
I guess I next want to talk a bit about METR's policy work. So I think one thing people maybe know you for is, thinking about what's sometimes called responsible scaling policies. I gather that METR had something to do with Anthropic's responsible scaling policy. Yeah,
so I think the history of that is roughly like Paul and I, and then Hjalmar, and sort of, I guess it was evals days, we're thinking about this kind of thing since I think like late 2022. We were kind of thinking, what in particular should labs commit to, or how to kind of evals fit into things. What would a lab be able to say that such would be like, oh, that's like seems about as good as you can do in terms of like what makes sense to commit to or something. And originally thinking more like either some kind of safety case thing that's relatively unspecified, and more just like you have to make some kind of safety case and there's some kind of review process for that, or and then I think we ended up thinking a bit more about like or maybe more like a standard, and we can say like you need to do these specific things at these specific times after you run these specific evals. I think, as sort of Anthropic was also excited about making some kind of thing like this happen. I don't know quite like when Paul was talking to them, or there's definitely some amount of independent development or whatever, but specifically the like responsible scaling policies and the idea that this is mostly centered around like red lines and like when is your commitment that you would like not scale beyond this, I think was like mostly an idea that came from us. And then Anthropic was the first to put this out. We were been kind of talking to various other labs and kind of encouraging them and trying to sort of help them project manage it and sort of push this along. And now, so like OpenAI and DeepMind also have things like this, and like various other labs making various interested noises. The UK government like pushed for this at the summit, and like now a bunch of labs also at the Seoul summit signed a thing saying they would make these basically.
Sure. So I guess that's something to do with your work on RSPs. Is that like, is thinking about things like responsible scaling policies, is that like most of your policy work? All of it? Do you do other things?
Yeah, so there's a relatively core activity which I think is quite closely tied to the threat models and the evals, which is just like what mitigations do we actually think is like appropriate at different points, and that kind of ties in quite tightly to like what are we worried about and what are we measuring for. It's like what what do you need to do, what would buy you sufficient safety. And then there's the kind of a bunch of generic advising of just like people have questions related to that, and like governments and labs and various different people, and we just like try and say sensible things about like what do we think is evidence of danger, what do we think you need to do when, like all of these things. And then specifically this project of kind of trying to encourage labs to make these commitments and giving them feedback on it and help trying to figure out what all the hurdles are and get things through those hurdles. I think that's most of what we that's been the bulk of things that like, so Chris is our main person doing policy, and that's
Chris Painter.
Yeah,
gotcha. Yeah, so how, and in terms of just like what fraction of METR, like how much of METR is doing this policy stuff? Is it like one person on a 20-person team, or like half of it?
It's like 10% or something. This is just like mostly just Chris. Okay. And it's like somewhat separate from the technical work.
Cool. I'm wondering, so we're at the stage where a bunch of people, RSPs as an idea have kind of taken off. I guess people are maybe committing to it at this Seoul AI Safety Summit. Like, how good do you think existing RSPs are? And suppose that you had to like implant like one idea that people could have that is going to like make their RSP better than it otherwise would be. What's the idea?
Yeah, I think in terms of how good different RSPs are, I haven't actually read the DeepMind one closely, the one I'm like most familiar with, the Anthropic one, because I was like more involved with that. I think, I like the Anthropic ASL levels thing. I think it was reasonable, and they made like pretty clear and hard commitment to like, under these conditions we will not scale further, which I thought was good. And I think other labs RSPs had various kind of good ideas or nice ways to frame things, but I do think that was a bit less clear, really, when is the thing that you're making a really hard commitment, like, if X and Y happens, we will not scale further. Like, I think OpenAI's security section, when I read it, I remember coming away with the impression that it was more saying like, we will have good security, rather than like, if our security does not meet the standard, we will not continue. So I think just being clear about like, what is your red line? Like that, like when is it actually like, no, this is not okay. Not like what should happen, but like what are the clear conditions? And that would probably be the thing that I'd most like want to push people on.
Fair enough. So going back to METR's role in RSPs, or talking about policy, I'm wondering like the policy work and the science of evaluations work. Mm-hmm. To what extent are those sort of like two separate things budding from the same underlying motivation versus like strongly informing each other? Like, oh, we want these policies, so we're going to work on these evaluations, or oh, based on like what we've learned about this science of evaluations, that like strongly informs the details of some policies.
I think there's pretty strong flow, particularly in the direction from threat modeling and evaluations to policy, in terms of just like what do you recommend? Like what policies do we want? I think that, you know, there's a bunch of work that is like a different type of work, which is just sort of, you know, just kind of like project managing a thing from the outside and dealing with all the stakeholders and getting feedback and addressing all people's concerns and the kind of thing. You know, there's like ways in which the day-to-day work is different. But I think that in terms of like what it is that we were pushing for, what are the most important things, like how good would it be to get different types of commitments, what should be in there, what is the actual process that the lab's going to do, and then maybe some of the stuff in the other direction is just like feedback on what you know, how costly are different possibilities, how big of an ask are different things, like what are the biggest concerns about the current proposals, what is most costly about them. Like I think something we ended up, so I was saying like earlier on we were thinking more that we could make something that's more kind of prescriptive and is like, in this situation you need these mitigations, and then kind of became clear that different labs are in sufficiently different situations, or like different things are costly to them, and also just like depending on kind of uncertain future things of like what exact capability profile you end up with, that we either had to make something that had a lot of kind of complicated conditionals of like, you know, you must do at least one thing from category A unless you have B and C, except in the case of D, when right. You know, like, or that it was something that was sort of like very overly restrictive of like, well, this is obviously like more conservative than you need to be, but there isn't, it's hard to write something that's both relatively simple and not like way over conservative that covers all of the cases. So that's kind of why we ended up going to more of the like, you know, each lab can say what their red lines are, and then there's some like general pressure and ratchet to hopefully make those better.
Like what kinds of differences between labs cause this sort of situation?
You know, it's just going to be one of those things where I like can't think of an example or something. I think the sort of conditionals we were ending up with was sort of like security is maybe actually a good one, where like Google has like a bunch of, you know, there's a bunch of things within Google where they already have like, oh yeah, well, like here's how we do this for like Gmail protected data, where we have like this team with these air gap machines and blah, blah, blah. Like, right. Like there are some things that's like relatively straightforward for them to meet particular levels of security. Whereas for like OpenAI or something, this is like much harder because they like don't have a team that does that already or something. And probably similarly with some of the monitoring or like, you know, I don't know, process for deploying things like you know, it's like, yeah, just like larger companies have more kind of setups for that and more capacity and like teams that do this kind of thing, or I don't know, yeah, I imagine some, you know, some of the monitoring oversight stuff might be somewhat similar to like content monitoring type things that you already have teams for, whereas like maybe Anthropic or OpenAI would be more able to be like, oh, we did this like pretty involved science of exploring these capabilities and pinning them down more strongly or something, and like that's easier to do for them versus having like a very comprehensive like monitoring and security process or something like that.
Makes sense. So yeah, I guess I'd like to move to METR has, I think it's a bit not obvious what METR's relationship with labs is. So semi-recently, as of when I'm recording this, I think like Zach Stern Perlman like wrote this post on Less Wrong saying, hey, METR doesn't do like third-party evaluations of, you know, organizations, and they didn't really claim to. It's unclear why people believe they did, but from what you're saying, it sounds like there's some relationship, right? You're not just like totally living in separate bubbles, communicating via like press releases that the whole public sees. So what's going on there?
Yeah, I am kind of confused about the way there's been quite so much confusion here, but I guess what we mostly think of ourselves as doing is just like, you know, kind of like trying to be experts and have good opinions about what should happen. And then, you know, when we get opportunities, you know, trying to advise people or nudge people to do things or suggest things or like, you know, prototype, like, well, here's how a third-party evaluation could work. Like, we'll do a kind of practice run with you. And like, right. Maybe in future, like we would be part of some, you know, more official program that actually kind of like had power to make decisions over deployment there or something with us. Like, not something we've done already. Maybe this is partly where the confusion comes from, where it's like, well, we would consider various different things in the future, like maybe in the future we'll end up being some more kind of like official auditor or something. Also, maybe not. But then currently we're happy to kind of like try and help prototype things, and like we've tried to be pretty clear about this. I think like in the Time article that we did a while ago, like very clear, like what we've done are research collaborations, not audits. And like in the GPT-4 system card, it, like we say in a bunch of places, like this was not, we did not have the access that like a proper evaluation would need. And like, you know, we're just kind of trying to say some things. And like, you know, in fact, the model, you know, the model is limited enough that, you know, we could say some kind of reasonable things about it, like assuming that, yeah, we just still have to make various assumptions in order to be able to say anything really. Yeah, there's some question about what direction we go in future, or like are there other organizations that are going to come up that are going to do more of the like evaluation implementation, or that sort of like auditing and, you know, going down the checklist and sort of things like this. The thing that we're most thinking of, the central thing that we do is like, you know, being able to recommend what evaluations to do and like say whether some evaluation was good or not. And like this is a kind of like core competency that we want to exist outside of labs. Like at a minimum, there should be at least someone who can look at something that was done and be like, does this in fact provide you good safety? Like, what would you need to, you know, we can say something that you could do to provide safety. And then there's a question of like, does the lab implement it and it gets checked by someone else? Does the government implement it? Is there some new third-party thing that emerges? Is there like a for-profit that does it, but then there's some oversight from the government, you know, making sure that that for-profit doesn't, you know, isn't getting sloppy or something? You know, there's like all different kind of systems in different industries that have kind of configurations of the like, you know, the people who do the science of how to measure versus the people who do the actual crash testing versus the people who check that you followed all the proper procedures and all these things. So yeah, it's sort of, I guess it is kind of inherently confusing. So it's like there's a bunch of ways this work, and we want to help all the possible ways along, but aren't necessarily saying that we're like doing any of them.
Yeah. I guess like, yeah, it's just sort of a distinction between like METR trying to be, or the way I understand it, METR trying to be an organization, making it so that it can tell people how third-party evaluations should work, versus like METR actually doing third-party evaluations with some like gray zone of like actually doing some evaluations on GPT-4.
Yeah, I think the thing that was very clear, like
GPT-4, I should say,
like we should not be considered to be doing it. It's like, you know, we're not being like, hey everyone, it's all fine. We'll tell you if the labs are doing anything bad. Like we're making sure they're all doing everything correctly. It's like we have no power to tell them what to do. We have no power to disclose any, you know, in as much as we have worked with them on evaluations that's been under NDA. So like it's not like we had an official role in reporting that. It was just like, you know, then we can ask them for permission afterwards to like publish research related to the stuff that we did. But like it's not like, yeah, we've never been in a position to kind of be telling labs what to do, or to be telling people how labs are doing.
Sure.
Apart from based on public information.
Sure. Yeah, I guess getting to that relationship, like how, so you had early access to some version of GPT-4 to do evaluations. How did that happen?
They reached out to us as part of the general kind of red teaming program. And similarly, Anthropic, we had early access to Claude and various, but in addition to that, like various labs have given us, I can't necessarily talk about all the things we've done, and there's you know, kind of spectrum between like research support and just like, you know, have some credits so you can do more eval research, or like have you know, this like fine-tuning access or work with this internal researcher, or, you know, some other thing, you know, have this early model, not necessarily to do a pre-deployment evaluation on it, but just like to help you along sort of thing. Like various different things going on.
Do you know how much of the dynamic, or can you say how much of the dynamic is like labs saying, we've got a bunch of spare capacity, like let's help out, you know, this like aspect of science, versus labs saying like, hey, we would like to figure out, you know, what this model can do, or how worried people should be about this product?
Yeah, I think it has been somewhat more in the direction of like labs being like, hey, can you run an evaluation for us? And us kind of being like, well, the main thing we're working on is figuring out what evaluations should be, or like what evaluations to run. So like, yeah, I guess we can do a bit of that as a practice, but it's not like we're, this is a full polished service and it's like, yes, I will, put you in touch with our department of doing 1 billion evaluations or something. Right. It's like, well, yeah, I guess we can try and do something, but like, this is more of research than of like us providing a service or something.
Sure. Yeah, so sort of related to this, news that came out in the past month as we're recording is that a bunch of, it seems like most OpenAI former employees who left signed some documents basically promising to not disparage the company and promising that they wouldn't reveal the existence of the agreement to not disparage the company. You've previously worked at OpenAI.
Indeed.
You've also written something on the internet, like talking about this situation, but there's like a comment to something else. I think people might not have seen it. Can you lay out what is your situation with like your ability to say disparaging things about OpenAI, both now and when you started METR?
Yeah. So, yes, when I left OpenAI, I signed this secret general release, which includes the non-disparagement provision and the provision not to disclose anything about it. My understanding at the time was that this did not preclude saying things that were like obviously true and reasonable, like that, if it's like OpenAI's model has this problem or something, that
right.
like that is not an issue. But based on this is like not how you're supposed to get legal advice, but like asking the OpenAI person who was doing this with me, like what this meant or whatever, and just some general sense of like, well, obviously it would be completely absurd if this was like, you can't say completely true and reasonable things that might have a negative bearing on OpenAI. And that also I can't imagine a circumstance in which it would be in their interest to like sue someone over that, because that would just look so bad for them. So I kind of hadn't actually given this like much thought. Like, I think the other thing to point out is like, it's kind of narrow circumstance in which this would be the specific thing that's preventing you from saying something, like, because most of the things that I would say about OpenAI, like anything that's based on private information from when I worked there or from any relationship or anything that work that METR did with them would be covered under non-disclosure. So this is the only case where the non-disparagement protection in particular is coming into play is if there's public information but you want to say something about it. So yeah, basically I think I'd kind of forgotten that this clause existed also. And I think something that we've tried to do in our communication for a reasonably long time is being like, we're not like not an advocacy group. It's not a thing that we do to kind of like opine on how much we like different labs in some generic way. Like, we're here to say relatively boring technical things about like, we can maybe say things about specific evaluations we did or specific results or like whatever, but like trying to position ourselves as like, more like, I don't know, I guess what would the animal welfare example would be like, more like the people who go and like measure the air quality in the chicken barn or something than the people who are like writing angry letters or like, doing undercover recordings or something like, so, I think I mentioned that comment, like I sold my OpenAI equity. I can't remember if it was quite as soon as I was able to, because I was hoping I might be able to donate if I waited a bit longer, but I sold it all last year at least. I think I had either not read or forgotten that there was any provision of like they could cancel or claw back your equities. I don't think that, as far as I remember, that never occurred to me as a particular concern until all this stuff came up.
Okay. And so you sold equity last year. When, just for the timeline of METR, when does I guess ARC evaluations is what initially was.
Yeah,
when
so
does
I
that start?
Left OpenAI in summer 22 and went to ARC and was doing evaluations work, which was sort of talking with Paul and thinking about stuff and like doing some of this stuff we're talking about, like, maybe what should a good lab do, sort of thing. And I guess that sort of became increasingly a real organization, and like evals is a separate thing, and then became METR. I think I realized, I can't remember exactly when this was, that although I couldn't sell equity, I could make a legally binding pledge to donate it. So I pledged to donate 80% to Founders Pledge. I can look up the date if it's relevant, but
sure. How does one legally
so Founders Pledge is legally binding, which is nice.
Okay, so and somehow the reason it's legally binding is you're promising to Founders Pledge that you're going to give them a certain thing at a certain time?
I actually don't know exactly how this works. I just
okay.
remember that I was told this by the Founders Pledge people.
Okay.
Yeah, so then, OpenAI only has liquidity events every so often, but I sold all my equity when I was able to.
Understood. So I guess that gets to the issue specifically about equity and non-disparagement agreements. And if people are interested in that, I highly encourage them to read, particularly Kelsey Piper's reporting in Fox, as well as, OpenAI statements on this matter and Sam Altman's statements on this matter. I think more broadly, there's this question of, it seems like you'd want, as a third-party person, I would kind of like there to be an organization that is fairly able to fairly objectively say, hey, here's some tests. This organization is like failing these tests. Either explicitly say this organization is making an AI that's dangerous, or say, hey, this organization has made an AI that fails the like do not murder eval or something.
Yep.
And in order for me to trust such an organization, I would want them to be able to be like fairly independent of large labs. Large labs have some ability to kind of throw their weight around.
Yeah.
Either via sort of non-disparagement agreements or via like, we will or won't cooperate with people. We will or won't like let you have access to our new shiny stuff. I'm wondering, from the outside, how worried should people be about, how independent organizations like yours can be of big labs?
Yeah, I mean, we have very little ability to, provide this kind of oversight, largely because there is no mandate for us to have any kind of access. And if we do have access, it'll be most likely under NDA. So like, we can't say anything about what we learned unless the lab wants us to. So until such point as there are either like voluntarily or by some industry standard or by government regulation that like external evaluators are mandated access and that access meets various conditions, such that you can actually kind of do a meaningful evaluation and that you're permitted to disclose something about the results. No one should consider us to be doing like this kind of thing. And I'm not aware of any organization that does have this ability. I think the executive order on AI does require labs to disclose the results of evaluations that they do to NIST, but I think it's unclear whether they can actually mandate them to do any evaluations. And like, then there's also not necessarily any oversight of exactly how they do them. It's like, I actually don't know what the legal situation would be if you just like did something very misleading. But at least you could, you can imagine a lab do something very half-hearted or sloppy and like provide that to the government and they've like technically met all the requirements or something. So I think this is very much a thing that is needed. And I feel bad if we gave the impression that this like already existed and wasn't needed or something, because that was like definitely not what we were trying to do. Or sorry, as in, it would be great to have this and we would be happy to be a part of it if we could be helpful, but we were not trying to convey that this was already solved.
Sure. So moving back to science of evaluations things, your organization is doing like some work. There's some work that exists in the field. I'm wondering like things other than what METR does. What's your favorite in terms of evaluations work?
Yeah, I mean, like I said, I think all of the kind of domain specific stuff is important, and like
Hmm.
I know it does seem quite plausible to me that you'll get some. As I'm not quite sure about this, I maybe just don't know enough about it, but there's something that's in the direction of a more specialized model, more something like AlphaFold or something that actually unlocks. So, it's like then someone can use that to make like a way worse bioweapon than they would have been able to otherwise, and we're just like totally not covering that. And so I'm very, hoping that people are keeping an eye on that. I like Redwood's thinking about control evaluations, and like I think they're thinking carefully about like what exactly you can know under what circumstances, and credit to them for some of the things that I was saying about sandbagging and various other things as well. And I think some of the kind of model organisms and demonstrations that various different people have been doing is interesting also, and like scary demos or otherwise just like creating examples of things is something that we're not doing that much of, and it would be great for other people to do. I mean, people should do the things that we're doing as well. But in terms of limited capacity or like disclaiming, we are not covering having great scary demos. So hopefully other people will cover that.
Sure. Yeah, and in terms of like frontier research or research that people could start doing. So things you've mentioned so far: scary demos, understanding buffers, evaluations of things in just domains other than machine learning research. Are there any other things you would encourage people to do research into that are along the evaluations lines?
Yeah, I mean, we have this bounty up for just like tasks that meet various criteria, including sort of like not memorized and ideally sort of continuous score and various other things. So just like getting more of these so we can build a better kind of y-axis would be great.
If people are interested in that, do they just Google METR bounty?
Yeah, that should work. Or
okay.
Yeah, our website is metr.org.
Sure. So that's one thing.
Doing the solicitation, I guess there's the buffer covers a very wide range of things. So I think both like developing the y-axis on which you can measure it, or like being like, how does different ways of modifying tasks or different ways of assisting the agent and things, like how do these compare in size to like scale ups or elicitation effort, or all these, there's just like many different things that you can kind of plot against each other and try and calibrate like how big is this compared to that. And then other things are distilling. Yeah, like as I was saying before, this kind of whole chain from, what is it that we're worried about in the world, to operationalizing that in terms of specific tasks, to then kind of trying to get from these very expensive and unwieldy tasks to some easier to run tasks, and maybe to just like data sets or whatever. I think there's like a lot of different things to be done there. And in particular, something that we tried to do for a while, but ended up moving on to other things, which was kind of hard, and was creating a classification data set that captures the hard parts of doing a particular task, and like finding something where it's like you can make some kind of case for upper bounding based on like even with a reasonable amount of data and fine-tuning on this classification task, the model can't manage to kind of identify whether it's currently doing something sensible towards its goal or not. Like that is something nice that gives you a stronger guarantee about the model not being able to do that kind of thing. And maybe fits into the sandbagging stuff as well, like creating model organisms of sandbagging. I think, we also would love to be doing more stuff on alignment and control evals, and thinking of like, okay, once you're no longer at the point where you're being like, the model doesn't even have these capabilities, then what do you do? How are you testing that? What would labs need to be doing? I think there's a bunch of more fleshing out threat models that would be great. Like, I think particularly maybe like some of the persuasion and things like that could do with more specification of like, okay, what exactly is it that happens? What are all the other capabilities that are required? And exploring some of this, like, what kind of coordination does the models need to do with these different threat models which ones can we be ruling out based on the model's ability to coordinate and take considered actions between different instances, and like which ones, if we saw that changing, like with people creating models that were communicating with an uninterpretable state, like how would that change all our thinking about threat models, or like then what evals would we want to have? I don't know. There's a lot of stuff.
Yeah, that's a lot of things for listeners to go off of. So that's things they could do. If listeners are interested in your research or your works, how should they follow that?
Yeah, so we are hiring, particularly for ML, like research scientists and research engineers. We're kind of very bottlenecked on this at the moment, particularly for just implementing these ML research tasks. You need ML researchers to actually know what the tasks are and construct them and test them. And more generally, basically all of the things I've been thinking about, things I've been talking about, the sort of science of evals and building the y-axis and getting, distilling hard tasks into easier to measure things and buffer and all of those things. It's just like a lot of science to be done. Just like build the tasks, run the experiments, see, kind of de-risking, like, does this whole paradigm actually make sense? Are we getting the, can we make predictions about the next generation of models and what tasks we'll see fall in what order? Like, do we actually understand what we're doing here? Or is it just going to be like, oh, actually these tasks just fall for a bunch of dumb reasons, or like there's not really capturing, something that's actually threat model relevant. Like anyway, yes, sorry. Hiring. Yes, we are hiring specifically ML researchers and research engineers, but generally we're still a kind of small team and excited to kind of fit outstanding people into whatever role kind of makes sense. Like, we're still at the stage where it's like, for key people, we will build the role around them, and I think there's a bunch of different things that we could use there.
Sure.
Yeah, and then the task bounty and also baselining. It's just like, we just need people to create tasks, test them. Yeah, if you want to have your performance compared against future models, be the have your performance on this engineering task be the last bastion of human superiority over models or whatever. Get in touch, I guess.
All right. And what places do you sort of publish work or write about things that people should check?
Oh, geez, we really should write more things up. We have the last thing we put out is this autonomy evals guide, so kind of collection of different resources. Like, there's like a repo with our task suite and another repo for our task standard, and some, various different bits of writing on how we think people should run evaluations overall and elicitation, and some results on like elicitation, scaling rules and things. That's the link from our website.
Sure. Great. Well, thanks for coming here and chatting with me.
Awesome. Thanks very much for having me.
This episode is edited by Jack Garrett, and Amber Dornace helped with transcription. The opening and closing themes are also by Jack Garrett. Filming occurred at Far Labs. Financial support for this episode was provided by the Long-Term Future Fund, along with patrons such as Alexei Malafeyev. To read a transcript of this episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about this podcast, you can email me at feedback@axrp.net.